Hi everyone, I'm Dmitry Shmoylov, and I'm head of software security at Kaspersky, which is responsible for secure development lifecycle implementation. Secure development is a major focus in the software development industry. For big software development companies, it's already a must, and they have their own criteria. It might look easy enough. You take the entire secure development process, break it down into stages, and add some security to each stage. But there's more to it than meets the eye. Firstly, you need the right expertise, the right tools, and well-established processes so you avoid critical mistakes and end up with a bad product. Control is also crucial. Most importantly, all these things should come together to form an ecosystem and culture of safe development. If a company can do this, it's a success in terms of having the most secure development processes. At Kaspersky, we've been doing this for a long time and have enough experience to be confident talking about it. First of all, it's not free, especially at the start. At the starting point, secure development can consume up to 15%, even 20% of the development team's resources in total. Because starting the process is hard, unfortunately, that affects the development speed. So nothing is free, but it can be optimized. Every role that in one way or another influences development needs to be involved in these processes, from regular developers to project managers and even the technical directors of development departments. There also needs to be an understanding of our full responsibility for ensuring product quality and security. People use our products everywhere, and we know very well what a security error in security products can cost. We believe we've set up good control, including security gates. The development team has its own dedicated security experts, security champions. They help increase productivity significantly in terms of the safety of our processes. We have our own bug bounty program. We use a huge number of tools to verify our code. All this is important in terms of consistency. Product after product, release after release is checked the same way with standardized quality levels. This isn't just the down to one department. It's thanks to everyone involved in the entire development process. All involved accept responsibility for the quality of code they release. You might even say that our expertise center only organizes and monitors this process. In terms of challenges, we have our fair share. First of all, security products inside systems generally have high privileges, and mistakes made in processes with high privileges can lead to big problems. We want to avoid this, so this is one of our challenges, and we closely monitor highly privileged processes. Also, we are a constant target for attackers. They love to go after security tools because once they're in, they can leverage these same high privileges. So, control needs to be constant. This is part of why we have a bug bounty program, cash rewards for researchers who find bugs, which also plays its part. You can find the results of their research on our website. Will secure by design be everywhere? I wouldn't say it like that. I wouldn't phrase it like that. Yes or no. I think the focus should be on when. Eventually, all products will be secure by design, because it's a gradual, planned development of the industry and development processes in general, integrating security in them. In other words, it's a question of when. In a perfect world, almost all products will be developed with the secure by design concept, as we understand it today. Why do I think that? Because the industry has evolved. We're talking about secure development right now. In the past, nobody even thought about it. The main thing was that the product worked. Now, secure development is the first step towards secure by design. Let's think about what secure by design actually is. It's not the security of software imposed from outside, not patches applied to it, but one that is incorporated at the initial design stage in its architecture, in the conceptual idea of the product. When people think about their product, they start developing it functionally, considering all the threats that may affect it. This is precisely the meaning of the concept, not means applied afterwards, but means provided by the product itself. This comes with its own difficulties. The first is architecture. A product that's not built with security in mind from the start can hardly receive as venerated a designation as secure by design. A patchwork approach to security issues also won't change much in the big picture. It needs to be part of the foundation. In Kaspersky products, we're always thinking about security, and we make it part of the architectural level where we can. Sometimes there are restrictions dictated by the operating system, the environment where the product operates. This environment, from a security point of view, is sometimes immature, and this got our engineers thinking about the concept of their own operating system, which would be secure by design. And you guessed it, that's Kaspersky OS. From its very inception, it's an operating system designed to be secure. We've been talking about secure development, SDLC and SSDLC. We've also talked about secure by design, or structural security. Cyber immunity is another approach to security and secure product development. For the most part, it's secure by design as Kaspersky sees it, with a few more nuances. I'll talk about them now. The first domain where we can talk about cyber immunity is Kaspersky OS. From the start, the operating system was built with security embedded in its architecture. Every call and every process interaction is controlled. Some actions are prohibited, others allowed. Security is in its very core. When development began, we started dealing with the question, where's the ideal level of security here? Where should we stop? We can over-engineer our solutions and make things secure that perhaps businesses don't really need. This is the advantage of the project, because security prevails. My team loves this project because all the security nuances we suggest to the development team are quickly accepted and applied, and sometimes we're even surprised at how fast we reach agreements with the development team. There are good engineers there who understand why certain things are needed and how. Now getting back to the balance between cost saving and security. Cyber immunity is secure by design as it concerns security goals and constraints. We determine goals at the development stage. In our constraints, we say, okay, don't focus on this because exploiting these potential weak spots is already too expensive for attackers. This doesn't mean that we ignore them in the architecture. We make constraints where they're truly necessary. It's a balance of goals. Here, other roles are also involved, like product managers who understand where this product will be used. Engineers are normally on the sidelines for this. This gives us the chance to concentrate on what's important. How realistic is cyber immunity in general everywhere, like in every iron and TV? We don't always need it. We really don't. Why? Because some systems need to be made very quickly, on the fly. They don't require anything at all because they're too simple. They need to develop fast and, quite possibly, die fast too. But if these systems go on to live for a long time and perhaps become part of some critical infrastructure, then they'll definitely need to be reworked in terms of cyber immunity. That's just how it is. Here's one from within the last year or so. During a pen test of one of our products, we discovered a widely used open-source library on the attack surface and had to look at its contents from a security point of view. The analysis led our team to file multiple CVEs found in the open-source library. In fact, there were 2 such libraries and 2 attempts, and both yielded some found vulnerabilities. What does this mean? That open source is bad? In reality, no. It's written by people, and people make mistakes. It's the human factor. I wouldn't say these are the worst open-source projects out there. Ultimately, we just pay close attention to the security of code that goes into our products. The second case is more niche in terms of application security and secure development. In this case, we used various static analyzers on the code, and they didn't find anything. But one of our experts did. Then we made a rule, tweaked the static analyzers, and they started finding similar errors, including in the code. It was a bit of a surprise for us that the analyzers didn't find this, even though they should have. But again, it's a question of complexity and detection of a specific type of error. The complexity of our code as well, because our developers are system developers. They work on systems that may never be used in standard desktop applications. So the code was highly optimized. What's the best way to become an expert? Never stop learning. Gain experience and don't be afraid to ask questions. You should be motivated by your own interest too. When you're interested, the road to self-development, understanding new things, and broadening your horizons is always open. Our center is well staffed, but at interviews we see how younger specialists have a fire in their eyes, and in a way they're pretty close to the level required for the team.